before we get into tools and we start working out with those tools, let's try to figure out, what is primary objective of service virtualization. And there are various different comparative paradigms that we need to be clear with so that we are able to identify what all are the critical scenarios in which we will go with service virtualization. And then I'll be talking about various tools which are there and what is benefit, or you can say pros and cons of those tools. This is what is going to be the first part of the session. And then we'll start up with Mockito, followed by WireMock. Once we are comfortable in this, believe me, we'll be able to handle any service virtualization tool. I am also focusing on containerization, how actually we will containerize, use Docker, and also try to figure out how actually containerized services can also be one of the candidates of utilizing service virtualization. That is what is overall objective. In short, service virtualization is all about simulating behavior of components which are not available or are difficult to access when you are testing. That's what is the primary objective. Now, what all are the components whose behavior would be right candidate for service virtualization? You might have used database, APIs, network, and when you specifically go for IoT, various devices, right? So there are multiple reasons why actually your resources are not available or they are difficult to access. Sometimes your component might be in development. Sometimes it is difficult to set up. Sometimes, cost can also be one of the restrictions. Sometimes they might be owned by third parties. So through virtualization, as a test engineer, I don't need to depend, or I'm not dependent on those assets, or my team is not blocked, and we can continuously focus on integration testing at any point of software development lifecycle. Right? That's what is primary objective. So what I need to do, I need to mimic or simulate behavior of what? Of components. Of what type of components? Components which are unavailable or we are finding difficult to access from perspective of cost or from perspective of ownership. Right? That's what is overall objective of service virtualization. We need to be on same page when it comes to various different type of testing methods. When we talk about testing, right, there are multiple school of thoughts. There are multiple different testing paradigms that actually we come across. So two things are there that we need to be aware of. One is type of testing and second is testing levels. Because we have to ensure that our product is bug free and we are able to implement or adopt DevOps principle of continuous testing. We need to first understand what type of testings are there, what type of approaches are there that are actually involved, when it comes to testing. See, primary objective when you start testing is to ensure that, whatever is under test, it meets the testing criteria. So there are various different ways of doing it. One is manual testing. I don't feel that I need to explain you. In manual testing, you need to identify action, formulate a test script, and then derive expected result. Actual result, map it. In case if it is fine, it means that test has passed. Right? So in short, this is what is manual testing. In some kind of applications which are monolith and which are legacy, manual testing is still being followed. Then comes automated testing. Automated testing is all about how do you specify a pipeline in order to automate your testing. Because automated testing will not only find bug quicker, but automation also improves precision and accuracy of test. So that's what is the objective of automated testing. Now there are various different tools that you can use in order to derive a pipeline and implement your automated testing. Then comes data-driven testing. See, when we adopt automated testing, data-driven testing can be one of the ways to utilize your automated testing. In short, there will be data table that will contain all the conditions. Those conditions will include test inputs as well as appropriate outputs using which you can verify. And understand that in data-driven testing, every row in the table will be a new iteration. That's what is data-driven testing. Then comes one of the testing which you would like, and that is exploratory testing. These are also called as scripted testing. In this case, we know what the acceptance criteria is for every test. And we also know what is the condition that need to meet acceptance criteria. So exploratory testing can be considered as acceptance testing. Now, there are many issues with the acceptance criteria that you need to highlight, and exploratory testing is one of the best way that helps you to recognize potential issues with only a brief summary that explains the expected behavior. Then comes the last one, which is ad hoc testing. It is in some way similar to exploratory testing. Now, you need to understand the basic difference. With exploratory testing, you will have some knowledge of expected requirement. I mean to say the user knows what the expected behavior will be. So tester is able to take an unscripted but logical approach to derive test based on information. But with ad hoc testing, there is no information. The testers randomly selects and guesses what the test should do and how to write it with those guesses and random selects. So these are different types of testing that actually you need to be aware of. There are four derived levels. One is, let me start from first, that is unit testing from the right, where every component is tested. I know you are aware about unit test. When you start testing your component element, I mean to say every component or the smallest piece which can be tested, you will be able to identify bugs early, and this will eliminate the cost of fixing defects. Then comes integration testing. Now, for integration testing, you take all the tested components which are well tested in unit, and then you test how they are collaborating with each other. And then you move with system testing, and finally acceptance testing, which ensures that whatever testing you have done and the end user is satisfied with the current behavior of your components. So these are level of testing, basically intend to tell who is the candidate and how actually those candidates will be satisfied with the kind of outcome that your testing gives. Now we are going to move to the core, and that core is service virtualization. And this is what is our agenda as well. I've already given you a brief of service virtualization, and that is it mimics or simulates behavior of components. Components can be IoT driven, database driven, API, network, which need to be deployed on-prem, on cloud, containerized, right? There are multiple different destinations. Now, through virtualization, I am relieved because there is no blocker. There is no showstopper for my activity. Why? Because I can go and I can adopt virtualized services, right? Those virtualized services need to be tested with kind of input that they will receive and what is the expected output. There are tools which will help you to derive your endpoints and base all your tests on those endpoints. Finally, you can say that last point in the service virtualization, it allows for more in-depth performance and functional testing, and it all can be done in parallel. So this is what is a fundamental objective. I will summarize here about service virtualization by saying that service virtualization provides me opportunity as well as testers opportunity to ensure that they're able to provide high quality product or high quality test outcomes throughout the entire software lifecycle. That's what is objective. Now, after understanding what is service virtualization, focus only on these things. How do we mimic? How do we simulate behavior of component? How do we derive interface? How do I set up virtual servers or mock servers? So these things are there that you need to ask, and all these questions will be answered once we move forward. But I was asked about, to tell you what all are the critical benefits which are associated with, service virtualization. We all know that when I say virtualization, it means it is going to hide or abstract the actual component. That's what is meaning of virtualization. Primary objective of service virtualization is to remove all the dependencies and associated troubles. And when we are able to remove all the dependencies and we are able to test, there are certain benefits that we can realize out of it. First is we will be able to manage our test without dependencies. And if you ask me, what are these dependencies? See, these dependencies are those components on which your test is dependent. It means without those components being ready, you cannot further test your service functionality. Now, you can have internal as well as you can have external dependencies. And service virtualization helps you to manage both internal as well as external dependency. Now, what is this internal dependency? See, internal dependency is a component that is being developed in-house, but unfortunately, it is not fully ready. And external dependencies, obviously, you are dependent on some third party, right, which is not in your control and may not be available. So these are, external and internal dependencies. Now, when you are selecting your service virtualization tool, you need to always compare them on basis of how quickly a particular service can be spinned up and you can start interacting and testing them. So that's what is objective of service virtualization. It eliminates dependencies and it helps you to build a virtual system using which you can test. Once your code is tested early, it will reduce time to market, and that's an open fact. Because typically software development life cycle may, have long waiting time because third party or internal dependencies are yet not ready. So API developer might be waiting for someone to release component using which you will be able to test your code. Now, when we use service virtualization, which helps us to simulate components, we can move faster, we can work in parallel, and we can conduct all types of tests, which in turn gives us better productivity. So this is what and how, service virtualization can reduce time to market. Now, third important benefit of service virtualization is it allows us to have better control over our testing environment. See, if I want to derive quality out of my product, I need to test keeping in mind multiple different conditions. And that's where virtualization comes into play. It helps you to quickly build service API, and on those service APIs, you can go and you can do different type of tests. And since we are not dependent, we can do all these tests early in the development lifecycle as we are not blocked now. Another feature that service virtualization provides you is that you can replicate. You can replicate what a service does within that particular environment itself, and that helps developers to understand how it will interact with other part of the system. And this is where you will be able to measure quality, and you'll find that now your product is more productive, less risk is associated with that because you have tested using various conditions. And it also helps you to identify issues early and flag them. So this is how it increases quality. Now, some people tell me that, see, how it is going to reduce cost. Now, assume that you are dependent on some Lambda function, which actually is deployed in AWS. Now you are going to test. When you will test, you will make calls to that Lambda function. And, most of the cloud systems are build as you use them. So you will have some service charge associated. But when you are using service virtualization, it helps you to reduce cost, right? By mimicking this service, which actually is present in a third party environment where you are being charged for each call. This is first benefit that you get from perspective of reduction of cost. Second benefit is when you virtualize your service, you actually reduce infrastructure and operating expense. And obviously labor cost that is associated is also less. So this is how when you are using service virtualization, you will be able to manage, you will be able to control the cost. So if someone is asking you that why we are going with service virtualization, simple reasons are, I'm not dependent. It helps me to quickly test and hence reduce time to market. I can use virtual service and replication of virtual service that helps me to test using various different conditions, and that enhances, the quality. And finally, I'm not dependent on calls that I'm making to third party where I'm being charged because I have virtualized it, I have mimicked it, I have simulated it, right? This is how it reduces the cost. So with these benefits, we can say service virtualization can be one of the candidates if your current testing need meets all the fundamental requirements and drives you to service virtualization.